Hi everyone, I'm Zdenek, CTO at Codasip, and today I'd like to show you in a really short video the compiler capabilities that Studio provides. Here what you can see is just a simple example of some application, and we will focus on the average part of it. So there is a math that basically computes average of two values. What you can do in Studio is you can compile this and you can debug and profile this application to find out what you can do with the application, how to improve the performance maybe. What we can do at the moment is that we can indeed start simulating. So let's go with the cycle accurate simulation. And as you can expect, we can do certain items, and at the end we're going to have a nice report of the average values, which indeed is from 10 and 20 is 15. But let's focus more on the compiler side at the moment. So let's see what the compiler did actually. So we built with the vanilla compiler, which means no extensions. And if you look at the assembly and if you look at the average function, which is over here, we can clearly see that we have a load of those two values from stack. Then we have the addition, and then we have a shift, because shift does divide by 2. This is debug build, so we can see the instructions very nicely. And the next step that we can do is, okay, let's add the average instruction into the instruction set, so we can enjoy the optimizations. And also the fact that the compiler will pick up this instruction automatically. This is exactly what I did. So if we go to the model and let's focus only on the additions to the CPU, then we indeed have the instruction that represents the average instruction. And if you look at the form, how it's written, it's quite easy to follow. We have the assembly, which is the textual part of instruction. We have a binary encoding, and in this case it's simple as well, because this is what the scribe specification tells you how to do. And then more importantly, you have the behavior of instruction in very readable form. And what's important from our point of view, besides reading the input operands and writing the result, is the computation itself. And the computation itself is quite easy as well. We have just a simple average instruction implemented over here. And this is all we need to do to add instruction and be able to generate not only compiler, but also the RTL. But if you focus back to the compiler and we regenerate all the tools, including compiler of course, then we can check whether the new instruction was recognized properly. We have a very nice report, in this case of the instruction report over here. So if I open that report, then we can go to instruction table, and we can try to look for the average instruction. And we can see over here that it is found, it is marked as usable, which means that the compiler will pick it up. As a proof of that, we can compile the average source code again, which I already did to save some time. And if you look at the assembly and of the average instruction, we can also see the loads and stores, because we are in the debug mode. But more importantly, we can see that the average instruction was picked up automatically as intended by compiler and by us to improve the performance. Of course, you can do much more complex instructions. The average is just an example, but it proves the point of having automation in the compiler. Thank you for watching.